Today we're going to talk about the periodic table of elements and its major groups and their characteristics. So we're going to start with the alkali metals, and we're going to go from left to right and then go visit these bottom groups down here. So we're going to make our alkali metals in red. That's not a straight line, but sorry. So our alkali metals are extremely reactive. They're extremely reactive because they have one valence electron. So having one valence electron means that you have one electron in your outermost shell, and every atom wants to have a full valence shell, or the outer shell, and have 8 in them. So alkali metals tend to react with halogens, which have 7 valence electrons, so they could meet with a covalent bond and have 8 valence electrons and fulfill the octet rule. So they tend to react with halogens. So let's say we're playing bingo and you have one space left. You're very anxious to get rid of that space and call bingo. In the same way, alkali metals are extremely reactive because they have that one valence electron they want to get rid of or combine with another element to get 8 electrons. So let's do our alkaline earth metals in orange. Okay, so our alkaline earth metals are less reactive than alkali metals because they have 2 valence electrons. And going back to our bingo example, if you have 2 spaces left in bingo, you're not as excited to yell bingo once you get rid of those 2 spaces. You still have a sufficient amount of time to go. In the same way, alkaline earth metals are less reactive and less eager to get rid of those 2 valence electrons. Our next group is the transition metals, which is a convenient block right here. These are our transition metals. So our transition metals are fairly unreactive, but they are very useful as they are great conductors of heat and, more importantly, electricity. So these are our metals that we think of when we think of metals, like gold and silver and iron and copper and all of that. And these are very malleable, which means you could bend them very easily. This group are the metals, metalloids, gases, and nonmetals. So I kind of combined them all into this block. I'm doing it in green. Oh, and I added hydrogen as a alkali metal. I'm sorry for that. It is actually a metalloid, metal, gas, or non-metal. So that is going to be green. So metalloids, gases, and nonmetals aren't very active when it comes to reactions. They just don't do much because they don't turn into ions easily unless you bombard them with other ions. So there's really not much to them. Our next group are our halogens, right here in green, in this darker green. So halogens are very reactive. They're gases, so they're extremely reactive gases. And they react with alkali metals and alkaline earth metals. Okay. They have 7 valence electrons, and hence they're very close to that 8 that every atom wants, so they usually react with the alkali metals, or the alkaline earth metals, where they would switch electrons, basically. And then we have our noble gases right here. That is not a straight line. So noble gases are extremely unreactive. They're extremely unreactive because they have all of their shells full. Their valence shell is full. So let's say if you win bingo, you're going to be very noble, and then you're going to be treated like a winner, and you don't want to mingle with people if you are a very selfish and idle person. Or if you are a noble, such as a king or a queen, you think you're too good for other people, so you usually don't mingle with other people. Like noble gases don't mingle with other elements. Next we have our lanthanides. We're going down to this group, and I'll do them in a dark blue. Lanthanides, that's really not a straight line, I'm sorry. So our lanthanides are metals. They are metals, but there's nothing much special about them because they're very similar to the actinides, and it's very hard to distinguish them. So let's do our actinides in purple. Let's do them in this purple here. Oh, that's kind of dark. So actinides are radioactive, and that's pretty much all that distinguishes them from lanthanides. So actinides are radioactive, and lanthanides are metals, and they're very similar to actinides. So actinides are radioactive. Okay, actinides are radioactive, and the way I remember where each of these are placed, I always think to go from left to right, in exception to hydrogen. So I think the metals go first, and then the transition metals transitions the metals into more of a weird state, and then gaseous with the halogens and noble gases. And then at the bottom I have the lanthanides and actinides, and I always remember hydrogen as the weird one because it wasn't included in the alkali metals, and it's placed in a weird way. So in my terms, I call weird the junk drawer, which is the metalloid gases or nonmetals, which really are clumped together in what doesn't fit into other groups, but they also have very similar characteristics. I hope you learned something from today's video. Thank you for watching.